Hello friends, today we discussing about pop operation. So pop means if we want to delete elements from the stack, then how we delete it. When an element is here taken from the stack, so the operation is called as pop. So here I am giving one example and explain how the pop operation here taking place. So here look at this. This is one example. Three number of elements are within the stack. So one is 11, another is 22, another is 33. So already in the push operation, we know that whenever we enter one element, the top position is incremented by 1. So previously the top position is equal to minus 1. When we enter any element, so top equal to here increment 0. Then next is top equal to here 1. Then next is top equal to here 2. So now in this stack three number of elements are there. So the top is here indicating to the topmost element. So we know that in that stack we are doing the operation in last in first out. That means which element is here push into the stack last, we just pop that element first. Okay, last in first out. So the first element here, last element which is 33. Okay, so first we delete that element. So whenever we delete the element here, the top is decremented, top equal to top minus 1. Okay, so in the operation the top value is decremented and next the result is like this. Here look at this, 11 and 22, the two elements are there. Okay, and the top value is decremented by top equal to top minus 1, which is now 1. Okay, so previously the top value is here 2 and here now the top value equal to 1, which is decremented by 1 position. So next, if we want to delete the next element, so the next element is 22 and the 22 is deleted. Okay, so from this stack the 22 is deleted and after that the top is equal to 0. Okay, because the top is now once again decremented, top equal to top minus 1 and now it is 0. So after that, if we want to delete this element, okay, so now the top value is 0, here it is 0, top equal to 0, and after deletion of the 11, that means that now the stack is here empty. So what is the next top value? The top is once again decremented and the top value is now top is equal to minus 1. Okay, so here in this condition we check that if the top is equal to minus 1, top is equal to minus 1, if this is equal to minus 1, that means we know that the stack is empty, so further deletion is not possible. Okay, so for the pop operation we check the empty condition, which is also called as underflow condition. Okay, so that underflow condition is top equal to minus 1. That means whenever the value is equal to minus 1, that means the stack is empty. So if there is not any element present in the list, so how we just delete the next element, because already the stack is empty. So this is all about the condition of the pop operation. Okay, so now look at the algorithm, how we write down, and after writing the algorithm I explain once again by giving another example. Okay, so look at that algorithm. So first we write down the algorithm of the pop operation. So here the name of the operation is written as a pop. So first we write down step 1. Step 1. So step 1 is start. Already you know that in each and every algorithm you write down the start. Then step 2. Step 2 here you write down if top is equal to minus 1. Okay, that means you know that whenever the top value is equal to minus 1, that means the stack is empty. Okay, so then you write stack underflow. Stack is underflow. Okay, so next step 3. Otherwise, this is the if, then then we write down this, then otherwise means else, or you write down also otherwise, whatever maybe you write down else. Next, print the deleted element. So you write down the deleted element, you print it, whatever be element you here delete, you print it. Print the deleted element. Okay, so next is top equal to top minus 1, because we decrement the position, because the next element we want to delete. So the top is indicating now the next position. So top equal to top minus 1. Then step 4, we write down stop or end. Okay, so give an example I explain here. Suppose we want to insert 10, 20, 30, 40, 50 in a stack. Then we want to delete each and every elements. Okay, so how we delete it? So first, before this video, in the previous video, I already explained about that push operation. So you enter that 10, 20, 30, then 40, then 50. Okay, so suppose this is one stack. Okay, and the top position is here first. Top is equal to minus 1. Okay, so here the top value equal to minus 1, and then you enter this 10, so the top value now is equal to 0. Here the top value equal to 1. Here the top value equal to 2. Here the top value equal to 3. Here the top value equal to 4. Okay, so that means how many number of elements are there? There are 5 number of elements. Okay, so the top position is like a array, it can incremented from 0 to 4, which is size minus 1, and in the previous video we already discussed this thing. This is the push operation. Now today we discussed about the pop operation. Okay, so just delete all these and write down the topmost value. So what is the topmost value here? The topmost value is top equal to here 4. Okay, so we start our algorithm, and if top is equal to minus 1, then write stack is underflow. But here the top value is not equal to minus 1, so this if condition is not satisfied. Okay, else print deleted element. So this top element we want to delete, so print that deleted element, and then top is decremented by top minus 1. So top is decremented one position, which is top minus 1. Now the top is indicating to this position where the value is 3. Okay, then once again if we want to delete the next element, okay, so what we are doing, we check the same condition, if this is equal to the top position is equal to minus 1, so here it is 3. Okay, so we are not deleting we are deleting this element, and then once again we decrement it. Okay, and we store the deleted element. So the top equal to 2, next the top equal to 1, next the top equal to 0, next the top equal to minus 1. So whenever the top equal to minus 1, then what we are doing, we check that if this is the underflow condition or not, because in each and every case we check this condition if top equal to minus 1 or not. But here the top is equal to that minus 1, we assign the -1 value to that top. So we check that if the top value is equal to -1, yes, this condition is satisfied. So we write down the stack is underflow. That means there is not any element left to delete from the stack. Okay, so we go outside of that stack, and this here this message is shown in your screen. Okay, so this is all about that pop condition, means how you pop one by one each and every element from the stack. Thank you.